So looking at these extra examples, little warm-up problems, just to kind of summarize what we did yesterday. Direct substitution exists when you can just directly take that number, plug it in, because you have a polynomial and it keeps the denominator, if there is one, defined. Or it's because it's just like a linear equation, a quadratic equation, or maybe something that has like a cube in it. In this case, you can't use direct substitution because when you plug a 3 into the bottom, you get a 0. When you plug a 3 into the top, you also get a 0. Anytime you get 0 over 0, that's called the indeterminate. That means there's another way to solve the problem, algebraically. So, Libby, how could you alter the appearance of this equation to try and evaluate movements?
Split up the denominator into x plus 3 and then x minus 3.
Yeah, so the denominator can be factored, x plus 3, x minus 3. And then what happens, Libby?
You can cancel out the x minus 3.
Right. So the whole goal is to cancel the piece that's making it undefined. Well, the part that's making it undefined, if I plug in a 3, is that 3 minus 3. So they cancel. Libby, when they cancel, what does that do to the graph, even though we're not looking at the graph?
It makes the limit like undefined, or yeah.
Not undefined, but
It's like the N or DN or
not necessarily G&E. Sabrina, does it make it unreachable? It makes it unreachable because
there's no value there.
Yeah.
It's a hole.
there's a hole. So where this part cancels, if we looked at the graph in the calculator, you can't see the hole with the calculator. But when you graph it by hand, there is a hole because a piece is canceling. One piece, 1 point, cancels from the problem, not a whole part of it. So just that 1 point that's canceling actually creates the hole in the graph. So this limit, once we find it, I have a 1 on the top, x plus 3 on the bottom. So Libby, when you plug the 3 in, you get a limit of
1 over 6.
1 over 6. So there is a limit, we just say that that limit is not reached. And the reason it isn't reached is because there's a hole in the graph at that point. 1 point, the point that canceled from doing a little bit of simplifying. So I think one of the questions in your homework said, like, determine a second function where the graph is exactly the same as the given function. This is that function right here. It's exactly the same except at that 1 point where the hole is located. So original function, the new created function after doing some algebra is exactly the same shape, it's just it's missing a point. Questions?
Can you have it missing more than 1 point?
If there happen to be multiple factors that cancel, then yes, there would be multiple points that would have to be missing from it. So if I had maybe a quadratic on the top and like a cubic on the bottom, and we had 2 factors canceled, and I missed 2 points for everything canceled. Other questions? So the second type of problem, which there were 2 homework problems similar to this, have radicals involved. Again, if you plug a 0 in, you end up with the square root of 4 minus 2, which is 0, divided by 0. So anytime 0 divided by 0, indeterminate, that means find another way to solve the problem. How could you solve this one, Brandon? Right, multiply by the conjugate. And that actually is part of rationalizing it. Usually we rationalize the denominator. This time we're actually rationalizing the numerator. And that process is by multiplying with the conjugate. So the conjugate is the opposite sign in the middle. So Brandon, when we multiply by the conjugate, what do you have on the top when you multiply?
You have x. Plus 4 minus.
Right, so the x plus 4, the first 2 terms, because the square root times the square root cancels. We don't have the middle terms because they always cancel. And then you have the last terms. So the x plus 4 for the first term, and then negative 2 times 2 are the last terms. Do you multiply the bottom, Brandon?
No, you leave it.
Yeah, we're going to leave it in factored form because our goal is to get the part that was making it undefined to cancel. And if you distribute it through, then you no longer have that piece sitting out front by itself. Kayla, what happens with the top now?
The 4 negative 4 cancel out. And
And
then the
then-
X and the X.
Right, so these become 0, and then she said the x and the x can also cancel. If they don't cancel, and you end up with an 8, you probably multiplied wrong or you didn't use a conjugate. They have to cancel so that I can get that x term to cancel. So our new altered function is a 1 on the top, because everything canceled, doesn't leave you a 0. If things cancel, it leaves you with a 1. Especially when you're taking a piece on the top and reducing it or canceling it from the piece on the bottom. And then x plus 4, and then plus 2. So Kayla, when we take that 0 and plug it in for x, you end up with
1/4.
1 over 4. And again, that's not reached, because there was a point that was eliminated from the problem at x equals 0. So the piece that cancels is the location of where your point would be. Are there questions on the second problem? So I think the third one is the most interesting. Yes, you had 2 homework problems like it. No, we didn't go over any examples in class. Yes, we did these problems throughout the year. But maybe it vanished from your mind a little bit. Understandable, we learned a lot this year, so it is possible that things might kind of disappear from your mind. But again, if you plug a 0 in, I have 1 over 0 plus 3, 1/3, minus a third. So I get a 0 on the top, 0 on the bottom. That means you have to find another way to work through it. So if you plug a 0 in and you get 0 divided by 0, that tells you the problem can still be solved in another form. What do you think you usually do if you have 2 fractions with a minus sign or a plus sign in between those 2 fractions, Virginia?
We were trying to combine them.
We need to combine them. So we did partial fractions where we actually were trying to separate them. But we're using that same common denominator fact where we have to get a common denominator to pull those fractions together. Virginia, what would that common denominator be?
3 times x plus 3.
Yeah, the common denominator is just whatever's on the bottom of your 2 fractions multiplied together. And you can keep it in that factored form. When we did the partial fractions, we always kept our denominator factored. So the 3 from the one, the x plus 3 from the other one. And then to get the top, you're looking to see what isn't in the denominator. Well, the left one doesn't have the 3, so I need to multiply both parts by 3. So that means 3 times 1 has a 3. So that left fraction has a 3. The right fraction needs the x plus 3. It's really a negative 1. Don't forget to apply the negative because it's a minus sign there. So I have negative 1 times x. I have negative 1 times 3. So my common denominator enabled us to combine those 2 fractions together and end up with 3 minus x minus 3 in its numerator. Questions? Brent? No. So, oh, I forgot my little limit over here. Shame on me. The notation gods are going to come down and curse me since I forgot that little notation there. So, Brandon, how can you continue to simplify?
Well, the 3's on the very top will cancel out.
Okay, so he said the 3 is in the very top because that negative, and that negative is important, distributed with the 1 and making this a minus 3. These cancel. So now we have a negative x, 3 over x plus 3. So that's the numerator. The denominator says divided by x, but I'm going to make it into a fraction as well so that you see a fraction divided by a fraction. So think in your brains with all those concepts that you've gone over. What happens when you divide by a fraction? What are you truly doing, Michael, when you divide by a fraction? Yeah, you're multiplying by the reciprocal. So this guy right here is really multiplying by the reciprocal. That's what division is. And you actually learn dividing fractions in 5th grade. And they teach you first multiplying fractions, and then the next chapter is dividing fractions, or the second half of the chapter, and it really is just multiplying by the reciprocal. So you just learned it with numbers and not variables. When you're multiplying by the reciprocal, those x's can then cancel. And that really is our goal, to get that x to cancel. So we have x goes to 0. Finally, I got that x to cancel, and I have a negative 1 on the top, and the 3x plus 3 on the bottom. So when you plug in that 0, I end up with a negative 1. On the bottom, 3 times 0 plus 3 is really 3 times 3, gives us a negative 1. Right.
I did it a little bit more complicated. I just multiplied the denominator. I just multiplied x over 1 by
The x plus,
3x
yeah.
plus 9 over 3x plus
that,
9.
and then your denominators were totally the same. That works too. There are two different ways to do complex fractions.
I don't remember if you taught us that.
We
where-
did, yep.
Where like you cancel both of the denominators.
Exactly, yep.
And then you just left the numerator.
So this was method number 1, that was method number 2. Yep, they're two different ways. Questions? So I'd like you to flip backwards just one page, page 9. And I'd like you to look at the difference quotient number 5 on there and see if you can try the difference quotient. So see if you can try and like work through that difference quotient. It's the function x squared minus 1. And it gives you f of 3 plus h minus f of 3 divided by h. So we're going to take this and plug it in for x, like you did the opposite.
That's why I was trying to fix it, because I just like didn't have room and it was messing me up.
How was your trip yesterday? Fun? So you had that homework that was due yesterday. Okay, I would say you can get it finished. And I did ask about the book. I haven't gotten an answer yet. I got it to work on my MacBook, but I'm wondering if they did something to the iPad. So our tech, Miss Crater didn't get back to me yet. So thank you again. All right, how does this difference quotient thing work? Virginia?
You would plug in 3 plus h for x.
Right. And that's the key. So make sure that you're taking the 3 plus h and plugging it in for x. The f in front means you need to go to the function and apply it to the function. So you cannot do anything with the limit part because I can't divide by 0. But I can take that 3 plus h and plug it in for x. So it was x squared, but we're replacing x with 3 plus h. And then there's still that little minus 1. That minus 1 was part of the original function, so you just keep it. It doesn't have an x with it, it just stays. The second part says subtract f of 3. I'm going to put parentheses here. Because there's a quantity that you have to subtract, because my function is two terms. It's x squared minus 1. Virginia, what do you replace for x in this case?
Just 3, so 3
Yeah.
minus 1.
So that represents x. So in the function x squared, it's now 3 squared, and then again minus 1. But make sure you're subtracting that whole quantity. Both terms have to be subtracted, and then divided by h. So if something is squared, it really means there are two of them. How would you FOIL that? 3 plus h times 3 plus h. Grace, do you know what that becomes?
9, 6H.
And then there's still a minus 1. And then in parentheses, we have a negative 9, because 3 squared is 9, but the negative distributes. And that negative distributes to make it a plus 1. So Brandon, what happens with almost all these problems?
All the numbers that don't have an h with it cancel, and you can factor out an h from 6h and h squared.
So the numbers that don't have an h have positive and opposite terms. So positive negative 9, positive negative 1. The two pieces that remain will have an h in common, or the three parts that remain should have something in common so that we can factor that out. So factoring it out enables us then to cancel it out. So if you have something left that doesn't have an h in it and it's a number by itself, it means somewhere you missed out a minus sign probably, or a plus sign, because we need those pieces to cancel so we can factor out the h. So my resulting expression is 6 plus h. Don't forget the limit part. The limit part's the new part. We're now finding the limit when h goes to 0. So at the beginning of the year, we would have just left it at 6 plus h. But now we're finding the limit as h goes to 0. So when you plug that 0 in, you just get a 6. The two problems you had to do for homework that were the difference quotients, you, I think we're just using x plus h. And I know in 79, you were left with like 2x minus 3. So that had an x in the answer because there was an x in the problem. Here our x ended up being the 3 value. Questions? I didn't get to this part of the room for homework, so I will get there in a minute. But I want to start you off with looking at the review. So if you just flip to the next page in your packet. The first 3 problems, you have a graph. My graph seems to have vanished. But there are graphs for 1, 2, and 3. So you're going to use the graph to interpret the limit. There's 2 questions for each one. So you're finding the limit of the same graph at 2 different x values. At the bottom of that page, most of these are just like evaluating pretty basic limits. Like the bottom 2, you might have to do a little factoring. I'd like you to look at number 5, which would be on the back. So there's lots of algebra on the back. So like the front page, I think is pretty straightforward, minimal algebra. The top of the back is a little more interesting. You'll have to do some rationalizing, some common denominators. But looking at the bottom, this one was number 49 that we talked about yesterday. And these are the properties or the operations with limits. So you're given 2 limits of some function f of x and g of x. It doesn't say what they are. It doesn't give us a graph. But because we're applying an operation, it actually doesn't matter what f of x and g of x are. And we don't need the graph either. So if you look at A, it says find the limit as x approaches c of f of x divided by g of x. How do you really do that?
You just take the limit of x, correct? So f of x to 1/2 over 3.
Yeah. So literally, you're taking the limit of f of x, which they tell you is a half. The operation is division. So if I'm dividing my functions, that means I also do the same thing to the limits, divide them. So we have 1/2 divided by 3. That 3 really can be written as 3 over 1 because dividing is actually multiplying by the reciprocal. So 1/2 divided by 3 is really 1/2 times 1/3. 1/2 times 1/3 is 1/6. So you're applying the operation to the limit, not the function, because it's called operations with limits or of limits. If you just look diagonal, look at letter D there. So it says you have the limit as x approaches c of f of x squared plus g of x squared. So Brandon, really, what would you do there?
You would be taking, 1 over 4
Yeah, because you're taking 1/2 squared,
plus, and I already, put into common terms 36 over 4.
or yeah, sure, or you're taking 3 squared. So he said this is really 1/4, and then 3 squared is 9. That's supposed to be a plus sign. 9 is 36 fourths. He put it into common denominator form. So you have 18 minutes, which is a pretty good bit of time. There is another page, so there are 2 pages there. So it is a pretty lengthy review. I'm going to collect this from you tomorrow. My goal is to get it back to you on Friday so that you have pretty instant feedback on it. Tomorrow we're going to look at limits as a graph approaches infinity, which directly corresponds with horizontal asymptotes. Tomorrow is pretty straightforward, minimal algebra. It's more graphical. And then Friday, we're going to do a lot of graphing, like graphing a piecewise function and analyzing it at different limits. So one function, one graph, analyzing it at like 6 different limits. Monday we'll review, and then Tuesday we'll have our first limits test. And then the only thing to talk about is a derivative. So we'll have limits this week, and then we'll just go over a derivative next week. Kate, I think you have the physics test is on. Are you in physics, or is that just Chelsea? And AP, are you taking the AP test? No. Okay. So, I can talk to her anyway, 'cause I know the physics test is that. So, grab a partner. The answers are on Google Classroom, sent through Remind. I have them up here if you wanted to take a picture of them. Please ask questions. Use this to your benefit.